In today's lesson, we are going to be looking at the cosine law for finding side lengths. So just a little bit of a warm-up. We want to find this missing angle, right? So this should be a review from last lesson. So take a second, pause the video, and try to solve this question. Try to find that missing angle C. And when you solve this, you should be using the sine law to find this missing angle. We have a full pair and a half pair. We plug it into our sine law formula, the ratio between the A pair and the C pair. We're not going to worry about B. There's no information there. We go through, cross multiply, start to isolate for X, and we should find at the very end that we have an angle of 45.2. Now let's just look at the next one. In this one, let's try to solve the triangle. Can we solve this triangle? Can I find the other missing angles? So P, Q, and the other side R. Well, if I go through and I look, I have half a pair here, I have half a pair here, and I have half a pair here. Everything that I have is a half pair. I don't have a full pair to use, so I can't use my sine law. So this is where we have another law that comes into play to help us find, again, sides and angles for triangles that are not right angles when we don't have the information required for sine law. And this is called cosine law. So we're going to use cosine law again for dealing with acute triangles if we do not have a full pair and a half pair. And so we can use what's called cosine law. So we're going to have something similar to this, right? This is the same kind of triangle that we looked at for sine law, acute triangle, no right angles, and cosine law is going to look like this. So all variations of the same thing, right? The only difference is depending on which side we're looking for, or trying to solve for, it changes where the other sides are located or where the variables are. The main thing to recognize is the side that you're trying to find, you're using that angle or its corresponding angle. So in this case, right, so we have c squared equals a squared plus b squared minus 2ab times cosine c. Don't forget that cosine c, or that multiplying by the cosine of the corresponding angle at the very end. That tends to be a common thing that people forget. Again, the capital letters represent angles. The lowercase letters represent sides. Now, when we're using cosine law to try to find a missing side length, we're going to have two sides and a contained angle. And what we mean by that is we're going to need to have a side angle side, or SAS, or a sandwiched angle. So an angle that's contained between two side lengths, or it's sandwiched between them. And then we can use that information to help us find that missing side, which is going to be across from the angle that we have. So let's use the cosine law to solve for the missing side length. Again, we're going to go through, use our formulas to find it. So here, if we tried to use sine law, it wouldn't work. There's not enough information, and we do have a contained angle. This angle of 73 is contained between this side of 23 and this side of 22. So this is what I mean when we talk, or what I'm referring to when we say a sandwiched angle. There's an angle sandwiched between two sides. I'm going to use my cosine law because I'm solving for this other missing side, c. I'm going to use c squared equals a squared plus b squared minus 2ab all times cosine c. Now, if it's difficult to remember the three different formulas, even though they are very similar, relabel your triangle to match one of the formulas. Right? Relabel the points. Right? The points are just there just for reference, just to kind of let us know what angle we're trying to find, or side we're trying to find. But if we know what side we're trying to find, in this case C, relabel it. Make this A, and then the other ones C and B. Right? So that way you only really have to worry about one equation. So let's plug in our information. We don't know our side length, so we're going to leave it, but we do know A and B. A and b. So a is 23 squared plus 22 squared for b, minus 2 times 23 times 22 times cosine of 73. Now, if you're relabeling your triangle just to match or fit the one equation that you memorized or remembered, right, the other two sides, it doesn't matter which how we label them. I could say 23 is B and 22 is A. It wouldn't change my answer, right? Because we're adding the values. Same thing in the second part, because we're multiplying the values, it doesn't matter what order I put them in, it's going to be the same. I can go through and solve, and even though we can do this all at once on our calculator, I'm going to split it up into two parts. I'm going to solve the first part, and then I'm going to subtract whatever the second part is. So 2 times 23 times 22 times cosine 73. And I get 295.88. You want to be careful about rounding too early, right? So don't just round this to 296. I'm using 2 decimal places. You can use a bit more if you want, but we shouldn't be rounding too early. So 1013 minus 295.88. Get 717.12. Now looking at that, you might think, okay, that looks too big. And you'd be right. That is too big to fit our triangle based on the other sides that we have. And that's because this value is c squared. I want c, so I have to square root 717.12. And when I square root that answer, I get my side length, which is 26.8. So that is the side length, 26.8 units long. So this one tends to be a little bit easier. There's not too much rearranging that we have to do. It's more just plugging in and calculating. So it's very important that we recognize how to plug values into our calculator, how to properly enter them so the calculator follows the correct order of operations. Because you can make mistakes going through, and even if you're using the calculator. Next example, same idea, solving for side A, my other missing side. So here I'm going to use a squared plus b squared, or no, sorry, I already made a mistake. A squared equals b squared plus c squared minus 2bc times cosine A. I am using the cosine law because it is a sandwiched angle, A, and S. I'm going to plug in my values for B and C. Technically, B is the 29, C is the 30. Again, the order doesn't really matter in this case. So 29 squared plus 30 squared minus 2 times 29 times 30 times cosine 88. I'm going to go through, simplify the first part. Get 174 or 1,741. And I'm going to minus whatever what the other numbers multiplied are. So if you are going to use that minus and attach it to the 2 and make it a negative 2, then whatever sign your value or product has, that's going to be the sign separating them. If it's a positive number, it's going to be plus. If it's a negative number, it's going to be minus. I'm not including that negative. I'm just going to leave it out. I'm just going to put the negative and leave it there. So I'm going to do 2 times 29 times 30 times cosine 88. And I get 60.73, or we'll say 725. We'll add another decimal place in there. So again, the number when I multiplied all of these, or the product I got, was positive, but I'm leaving that negative out front, so it's going to be minus a positive, or just minus this value. A squared equals 1,741 minus 60.725. And we get 1,680.275. Again, the last step now, I need to square root that value. 1,680.275. And when I square root that, I get 40.99, or we'll say, not 50, 41. So then that is my missing side length. And so again, the difficulty with this is one, recognizing that we're using the cosine law, and two, making sure we plug the values into the correct spot. After that, it's just a calculation problem, so to speak. Looking at some word problems, an ice cream company is designing waffle cones to use for serving frozen yogurt. The cross section of the design has a bottom angle of 36 degrees. The sides of the cone are 17 centimeters long, and we want to determine the diameter of the top of the cone, or we want to determine what this value is here. So looking at our triangle, it's not a right angle triangle, it is isosceles. So if I really wanted to, I could find these two missing angles and then use sine law to find that missing side. But I'm going to go through and practice using cosine law just in case I forget what all the angles in a triangle have to add up to, or how to find those missing sides or angles. So I do have a sandwiched angle, side, angle, side. Now in this case, I don't have any labels. I don't have an A, B, or C. I'm just going to use a squared and say that's the side I'm solving for. So a squared equals b squared plus c squared minus 2bc times cosine A. Because I'm solving for a squared, this side opposite or at the very end, or at the very top for that diameter, right? That means that angle 36 is going to be for the cosine of that angle. The B and the C, it doesn't really matter which one it goes to, right? One, because it's the same value, so it won't make a difference. But two, because of the operations that are going on, the order doesn't really matter. So we have 17 squared plus 17 squared minus 2 times 17 times 17, or you could say 17 squared, times cosine of 36. A squared equals, and I'm going to go through and do it step by step. So 17 squared plus 17 squared, or 17 squared times 2, 578 minus 2 times 17 times 17 times cosine 36, 467.612. I'm going to subtract these two values. So 578 minus 467.612. We get 110.388, which again obviously does not make sense based off of the other measurements. Again, I have to square root that value. So when I square root that value, I end up with 10.5 or 10.51, depending on how many decimal places you want to round to, and it'll be centimeters. So 10.5 centimeters will be how long the top or the diameter of the cone will be. Example 3, 3 boats are at sea, the Chester 1, the Chester 2, and the Chester 3. The crew of C1 can see both C2 and C3. The angle between the line of sight to C2 and the line of sight to C3 is 45 degrees. If the distance between C1 and C2 is 2 kilometers and the distance between C1 and C3 is 4 kilometers, what is the distance between C2 and C3? Whew. A lot of C's there. But let's kind of go back and label it. So C1, doesn't really matter where you put it, can see C2 and C3. The angle for their line of sight, so from one to the other, is 45 degrees. 45 degrees. So now we have kind of our triangle. The distance between C1 and C2 is 2 kilometers, between C1 and C3 is 4, and we are going to figure out this unknown side length. How far apart are the other two? So I don't have a full pair, so I can't use sine law. It's not a right angle triangle, or I'm given no indication that it is a right angle triangle. So I have to use either the sine law or the cosine law. Again, no full pairs like we just said. So that means I have to use my cosine law. I don't have any sides labeled except for C, C, and C. So I'm just going to call it, well, I guess we can call it C. So C squared equals, we'll call the other two sides A squared, or A and B. So A squared plus B squared minus 2AB times cosine of C. C squared is going to equal 2 squared plus 4 squared minus 2 times 2 times 4 times cosine 45. I'm going to simplify both parts, although you can do this all in one step if you are comfortable with your calculator. So we have 20 minus 2 times 2 times 4 times cosine 45. And I get 11.314 rounded. We subtract that from 20. 8.686. And I need to square root that answer, 8.686. And I get 2.95. Use 2 decimal places. So in this case, that means that the C2 and the C3, the Chester 2 and the Chester 3, are 2.95 kilometers apart. So again, we have a new formula now because we can be given different pieces of information, and we want to be able to still find, or we want to use this new formula to help us find the missing side lengths of an acute triangle. Our next lesson is going to look for finding the angles using the cosine law. It's a slightly different formula. It's just rearranged, but it's a little bit more rearranged than we might expect to see considering what we saw with the sine law. Again, because it's a new concept, make sure that you are practicing these concepts. Practice putting it into your calculator because of how simple I get, or not how simple, there's no rearranging of the equation except for the square root at the end. But make sure you can enter this into your calculator correctly to use, or to tell your calculator to use the order of operations.